Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of domain and range of linear functions. This is standard A.2A in the great state of Texas, and we are using item number 49 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got this athlete running at a constant speed for 12 seconds. Part of the linear function shown represents the distance in y. So the distance is y right here. We see that distance on the y-axis. And then we do see that it's a function of time in seconds, x. So our time is the x-axis, and our distance is the y-axis. All right, looks like it's pretty straight there. So we have a linear function. Now, we simply need to identify the domain. If we were to look at our reference materials, we're going to see a lot of information. What we are not going to see, unfortunately, is anything about domain and range. So those are two terms that are usually taught together, domain and range. And honestly, domain and range aren't just for linear functions, right? We use them in quadratics. We can even describe the domain and range of exponential functions. So any type of functions, right, we're talking about, we should be able to discuss domain and range. So let's define those two, because once we define those, then we should be pretty good. So the domain here is going to be the set of all input values. So it's going to be viewed as a set, whether it be an inequality like we have down here, or if it's discrete, then most likely it will just be like a set of numbers, but it's the set of all input values. And then the range, if the domain is the set of all input values, then the range is going to be the set of all output values, which doesn't necessarily help you unless you know what we're talking about for our input and our output. So when we talk input and output, we typically will think of those in terms of x or y axes, right? So the input is what we start with. This is our independent variable, and it is always going to be associated with our x values. So when you think domain, you need to think the x values. And then our output is going to be our dependent variable because it depends on what happens with the independent variable. And it is viewed as our set of y values. So if you can just remember, the domain is the x, the range is the y, we're good to go. So let's look at our graph. We are looking at the domain, which means I want the set of x values. So what do we see here? Moving from left to right, you see that it starts at 0, and it goes to, looks like it goes to 12 right here. And you notice we have a closed dot there. That means we are going to be including 12 rather than excluding. If we had an open dot, we would exclude 12. So what can we say? X is going to be less than or equal to, because we're going to include 12, and it's going to be greater than or equal to, what's the other limit? It's going to be that 0. So we're going to put the bounds of 12 and 0 here, and that's how we would represent this with inequalities. We're not going to use 14 because 14 is just the last number shown on the graph, which the line doesn't go to. And then you notice we've got this 110 and 100, right? So here's the 100. This is the range. The range is described by that 100, and then obviously that 110 is just that next line up. Like that's the limit of the graph. They just needed 4 options. And so whenever you see domain and range, typically you're going to see both the domain and the range listed as answer options. You've got to pick the correct one. So we're dealing with the domain, and so our answer here is B.